to pay attention to all of them. So thanks everyone. Next on the agenda, without further ado, we have our presentation on seabed mining, the dawn of an industry and the need for a precautionary approach. Presented by Lead First, Twin Harbor Waterkeeper, and Liz Schotman, the Washington Regional Manager with the Surfrider Foundation. And it's my pleasure to introduce them. Lee first. For those of you who might recognize her name, she used to live here in Bellingham and did a lot of great work for clean water. I inherited her position, and she also has been on the Grays Harbor MRC, so she's very familiar with MRCs and how they work. And Liz Schotman also is as the Washington State Regional Manager for the Surfrider Foundation, has a pulse on what's going on statewide a lot of the time, and has a really rich background in biology, and her favorite fish is the mola mola, which I think is wonderful. So without further ado, I'll let you guys take it over. And if you guys have, if folks have questions during it, I didn't discuss this with Lee or Liz beforehand, but I'm thinking folks can just put their questions in the chat box, and then if folks at the end, we can answer those questions, or we can answer them, or you can ask them verbally at the end. I think we're a small enough group. So take it away.
All right. Are you guys able to see, do you see the slides or just
yes.
Okay, cool.
Looks great.
Hooray, success. All right, thank you guys for inviting us, and I'm super excited to share all the research I've done, and Lee as well. I do want to lead, I'm not a seabed mining expert, but I have been reading a lot into it, and it's pretty fascinating. I've been, quote, diving deep, pun intended. So we're excited to shed some light on this subject for those of you who are less familiar with it. So I'll talk sort of about what seabed mining is and the different resources that we are aiming to extract, or the global community is looking to the deep to extract. And then Lee will touch more on what those effects of that kind of extraction might have on our coasts and the Salish Sea. And then we'll also end on sort of what we hope to do about it. I'll skip this because we had an awesome introduction by Eleanor, because she's amazing. So I'd like to kick off this lecture, or this presentation, with a quote by Sylvia Earle, who is a renowned oceanographer and just all around badass explorer and woman scientist. And she has this quote that says, "What are we sacrificing by looking at the deep sea with dollar signs on the few tangible materials that we know are there? We haven't begun to truly explore the ocean before we have started aiming to exploit it." And I like this quote because it really emphasizes the need for us to take a precautionary approach when it comes to this new extractive industry. Because as we all know, working in conservation, history is fraught with hard lessons learned about destroying and impacting that which we do not fully know or understand. And the deep sea definitely qualifies as that which we do not fully know or understand. We've explored, I think, 0.01% of it. So we barely even know what's down there, let alone how all the ecosystems function or what they do for us on a global scale. Like, we're just now starting to understand those systems. So that's why we're trying to really emphasize the need for that precautionary approach before we just start sucking things out of the deep. So the shortest definition I could find is just extracting minerals and metals from the sea floor, obviously with more than just a glorified vacuum, but in some cases that's essentially what we would be using. But there are different types of seafloor extraction, and I do want to just differentiate between SGS, which is sand, gravel, and shell mining, which has been around for decades. It has its own set of issues that we're not going to be talking about in this presentation. So SGS is for things like beach renourishment and spoil island fill and things like that. I'm going to be speaking more to seabed mining, mostly about deep sea resources. So the deep sea is anything 200 meters or 650 feet deep or deeper. Although Lee will talk a little bit about more coastal resources, like black sands or mineral rich sands that kind of will also lump into that category of seabed mining. So if you start doing any research on this stuff, you'll end up reading a lot about the big three. So when you're looking at mineral deposits in the deep sea or in the ocean, There's three major sources, and they kind of have different combinations of materials involved, and they're located in different forms and in different locations in the sea. And so I'm going to touch on each of these in a little bit more depth, but the manganese nodules are little potato-sized chunks that are just laying around on what's called the abyssal plain, which are deep, just infinite sandy, silty expanses, just empty plains. And so that's where those are located. You also have what are called cobalt-rich crusts, which are lining the top of seamounts or underwater mountains. And then the third one are called seafloor massive sulfides. And so those are going to be located along hydrothermal vents. And feel free to shout out questions. I can't see the chat, so feel free to, feel free to interrupt me at any point. I don't mind. So for the manganese nodules, again, they're just, anywhere from, golf ball to potato-sized rocks that are just laying around, just like this picture here. And they tend to have a lot of copper and nickel, and importantly, cobalt and lithium, which are very important materials for things like lithium-ion batteries and a lot of electric, devices. And to collect these nodules, you basically just kind of pluck them up off the sea floor, which on the scale of, on the spectrum of extractive industries, doesn't sound like that big of a deal. You're not blowing anything up, you're just vacuuming up these rocks. But you have to think about it in terms of what that ecosystem has evolved with. So these are basically, the nodules are the only hard substrate within potentially thousands of miles. And so you have these deep sea communities, and a lot of those species require something hard to attach to. So in this bottom left picture, you can see like this is like a sponge or a coral that it needs to attach to something hard. And those nodules are often the only thing available. And then you see these diverse communities that can kind of grow off of these nodules. And so if you remove those nodules, there's nothing left for them to attach to. And so you lose that biodiversity and all the communities that are associated with them. And once they're gone, they're not coming back. These nodules grow incredibly slowly. It takes millions of years for them to become like a few centimeters in diameter. And so on our time scale, it's a non-renewable resource. They're permanently gone. And in addition to removing that habitat, you also have issues associated with just the disturbance of an ecosystem that is not evolved with much disturbance. And so you have bright lights and machinery making noise and just stirring up a lot of sediment. And Lee will probably talk a little bit more about those effects, but the deep sea is quiet and it moves at a very slow scale, and it's dark and it's cold. And so when you start bringing these heavy pieces of machinery down there, you're going to disrupt a lot of things. And we don't really have a good grip on what those different disruptions, what kind of effects they will have on those deep sea communities. Because again, we barely understand how these deep sea communities interact and do their thing. All right, where's my mouse? There we go. The second type are the cobalt-rich crusts, again, located on seamounts, underwater mountains. If you're like snorkeling above one, meaning you can hold your breath because they're usually hundreds of feet down or more, you would just see like rocks. But if you were to cut that in half and get a cross section, you see these thick metal, sometimes they're a few millimeters, sometimes they're like 10, 12 centimeters thick of this metal-rich crust. And they contain things, again, like manganese, cobalt, and other rare earth minerals. And in order to extract this, you need to basically plow it up off of the rock below it. So that's going to be much more destructive. It's essentially like underwater mountaintop removal, which is alarming because seamounts are incredibly important biodiversity hotspots. They're often like oases in the desert of the open ocean. And so, you often get upwelling events where you have that deep, cold, oxygen-dense, nutrient-rich water that hits the edges of these mountains and upwells and fuels a lot of primary productivity. And so seamounts are often very important for commercial fisheries, and again, attract a lot of cool, charismatic megafauna like whales and sharks and mola molas, and we have to protect the mola molas. And when Lee and I started to make the rounds and give this presentation, we would normally say this has not happened anywhere, and nowhere in the world have we actually extracted any of these cobalt-rich crusts. But late this last summer, there was a company that did sort of an experimental test extraction of it. I haven't been able to find much in the way of like published research on what the effects have been, because I think they're still analyzing it and working, you know, and doing all the follow-up from that experiment. But they did extract, I think, like 650 kilograms of cobalt-rich crust. So we'll see what the impacts are. You know, I'll keep an eye on that. So we don't really have a good, like, we can't say for sure what the impacts will be, but we can look to similar industries, other extractive industries, for some guidance. And we know that deep sea trawls that drag nets along these seamounts have severe impacts to biodiversity that can last for decades. And so that's just knocking things over with a net. So when we plow up the crust, we can only imagine that these will be pretty severe impacts that, again, will probably last a very long time. And last but not least, we have seafloor massive sulfides. And so these are like hard mineral chimneys that sort of grow around these hydrothermal vents. And they're really cool because these are chemosynthetic ecosystems. And so most of the life we know of on Earth derives its energy from the sun. Like the base of our food chain is photosynthetic organisms like plants and algae. But the sun could go out and these communities probably wouldn't even notice. They just keep doing their thing. So they get their energy and their nutrients and stuff from the minerals and the heat that just kind of boil out of the earth. So that's really cool. They tend to have a lot of precious metals like copper, silver, and gold. And to harvest them, you kind of knock them over and smash them up and then suck those pieces up to the surface for processing. And again, you just have these really unique communities that we're, again, just learning about now, like weird 6-foot-long tube worms and fuzzy lobsters and things like that. And so again, we don't know what the impacts of this kind of disturbance would be on them. There is some hope for the hydrothermal vent communities. Again, we haven't like tested this that I'm aware of, but these systems are a little bit more capable of managing disruption because the vents will like, you know, go cold or a new vent will start up. And so they're a little bit more adapted to some level of disturbance. But again, the pace of industry tends to be a lot faster than the pace of ecosystems, and especially in the deep. So I think that is all I have to say. I will switch it over to Lee. Lee, you should be able to just screen share and take over, but let me know if you need me to.
Okay. Thanks, Liz.
Yeah.
Hi, everybody. It's good to see your faces. I think I know most of you from my many years of living and working in Bellingham. So nice to see all of you. So I'm going to talk about what some of the effects are, or the potential effects. So some of the problems that we expect to result from mining the deep are listed here. Let's begin at the ocean floor. You can see a tractor type machine in this graphic that is connected via a pipe to a big dredge vessel above it. The tractor pumps manganese nodules or other items up the pipe to the dredge barge where the nodules are sorted and removed. The sediment is pumped back to the ocean. This dewatering plume or sediment plume will likely be very harmful to aquatic life. It will adversely affect fish, whales, and other creatures who navigate or breathe oxygen from the ocean water. We really have no idea how far the plumes will drift, but some models predict that the sediment plumes will drift from 10 to 100 kilometers. So as Liz mentioned, these operations will likely be very noisy, adversely affecting the ability of some animals to communicate. The operation will very likely affect commercially valuable species. And so the fishing industry could be impacted. And you know, it'll most likely affect ecosystem services such as carbon transport and biodiversity. One thing that I'm really concerned about is, you know, this is going to happen deep down in the ocean. So unlike a mine or an industry on land where, you know, most of the time we can actually see what some of the pollution problems are, this is going to be impossible for us to see and to see what the results are in most cases. Oops, I'm stuck here. Okay. So these are some slides showing an experiment that was conducted in 1989 called the Driscoll experiment. Scientists use a tractor type device to simulate mining disturbances in this manganese nodule field, which was located about 3,000 kilometers off the coast of Peru. The slides here show how the area recovered over time. The photo in the upper right corner was taken 26 years after the disturbance, and the tracks are still there. That photo down at the bottom right, shows the manganese nodules before the experiment started. Previous studies of this plowed area indicated that microbial abundance and density had undergone lasting changes. This study is important because it's one of the few studies that show the damage from mining. And I find this especially concerning because on land, we finally figured out how to do restoration sites on wetlands and rivers and such, but we really know nothing about how to restore the deep sea. So why mine the deep and why do it now? The primary driver of demand for these minerals is green technology, including electric car batteries, cell phones, and wind turbines. Mining for these minerals on Earth is becoming increasingly difficult, both because of the increased population of people and because of an expanding middle class that is driving urbanization and the need for renewable low carbon infrastructure. Plus, the amount of easily mined minerals on Earth is declining. So deep seabed minerals are increasingly likely to make an important contribution to sustainable development, especially for small island developing states that lack opportunities for economic development. The major mining companies around the world that are exploring or seriously exploring seabed mining are companies such as Blue Water, Chatham Rock Phosphate, De Beers Marine in South Africa, the Deem Group in Belgium, and Japan Oil, Gas, and Metals National Corporation. And in a lot of cases, these are combined efforts between the government of, say, Japan and an industry that is manufacturing the gigantic tractors and other equipment that's needed for deep sea mining. Why now? So many of these minerals, such as erbium, europium, and yttrium, are essential to our digital economy, and the transition towards an electricity-based transportation and information infrastructure is increasing the demands for these precious and rare earth minerals. There is increasing interest in phosphorus nodule mining and phosphorite from nearshore areas because phosphor-based artificial fertilizers are becoming more important to drive the world's food production. So I'm going to talk just a bit about a linear versus a circular economy. So in a linear economy, raw materials are cut, mined, and extracted, and then processed into a product that we use and usually toss out or it wears out. In forestry, for example, trees are cut, extracted, and processed into a product that most of the time has a finite lifespan. We call this a cradle to grave system. In a circular economy, raw materials enter a cycle where their value is maintained throughout their life cycle. When you're finished with something, it loops back up the chain to be reused somehow. A good example of this is the German car manufacturer BMW. In Germany, there is a legal requirement to recycle end-of-life vehicles, components, and materials with a quota of 85% for reuse and recycling. There's even a quota for the portion of automobiles that are made out of thermoplastic materials or plastic. So this map, I'm going to be able to point out some of the places where deep sea mining is planned and so on. So the majority of the resources we've discussed today are in international waters or the exclusive economic zone, which are the white areas on this map. And they extend from the border of the country and the sea to about 200 miles out. So Solwara 1, which is off the coast of Papua New Guinea, it was the first proposed deep sea mine in the Pacific, in the Bismarck Sea, approximately 30 kilometers from the coast of Papua in New Guinea. They had planned to mine seafloor massive sulfides, which are the rich hydrothermal vents formed by plumes of hot, acidic, mineral-rich water on the seafloor. But the people of Papua New Guinea protested this for years, and they called for a full ban on seabed mining. And because of the massive amount of resistance, the legal challenges, and funding difficulties, this proposal was shut down. So it's not on the table now. Whereas off the coast of Japan, you can see I have the word jogmek there. This was actually the first, this has been mined. The deep sea has been mined here. The jogmek and the country of Japan has conducted the first successful excavation of cobalt-rich seabed in the deep ocean. And then you can see off the coast of Peru, there's the disc hall there. I talked about that, where the deep sea tractor plowing happened. And then over on the west side of South Africa, there is deep sea mining kind of in coastal areas for diamonds. So closer to home, this is my area. This is the Chehalis watershed, the Chehalis River watershed and Grays Harbor. We have documented black sands or mineral black sands in Grays Harbor, and they're also down all around the mouth of the Columbia River. So these black mineral sands contain small amounts of gold, platinum, chromite, iron, titanium, zircon, and garnet. So that's very concerning, because these are really important areas to protect and conserve. And should deep sea mining occur in these areas, the drift from mining these areas could extend north into the marine sanctuary that's on our north coast. This map shows the extent of Washington State's jurisdiction. From extreme low tide to 3 miles offshore. The hatched area is the National Olympic Coast Marine Sanctuary. The pink is the Washington State waters. We, Surfrider and Twin Harbors Waterkeeper, are partnering with the Pew Charitable Trusts to do this outreach work. As Liz said, we want to get ahead of this issue. We want as many people to know about it as possible. We also are going to be working with some of our legislators in Washington State to try to introduce a bill to ban this before it starts, either this year or next year. it's interesting that Oregon banned seabed mining in the 90s. And there's also an effort in California that's a little ahead of ours to ban it in state waters of California. This is just a close-up of a manganese nodule and one cut in half. So as Liz said, these are about the size of a potato to a head of lettuce. They contain mainly manganese, but they also contain iron, nickel, copper, titanium, and cobalt. These are of great interest for mining because they contain greater amounts of some metals than are found in today's economically mineable deposits. And it is assumed that the world manganese nodule, that the manganese nodules on the seafloor contain much more manganese than the reserves on land. One thing that I find especially interesting about deep sea mining is the potential of environmental damage. So, you know, we've all heard that land mining has caused huge problems. It's had huge impacts on water, ecosystems, and human health. It releases on land, mining releases more toxic substances such as mercury, arsenic, lead, and cyanide than any other industry in the United States. And those are just a few of the side effects of mining on lands in the West. There's also been cyanide spills, habitat destruction, and fish kills. There's been water pollution caused by acid mine drainage, which leaches potentially toxic heavy metals like lead, copper, and zinc from the mining operation. So this slide actually shows a zinc mine in China. And after an 8-year study that began as a state secret, the Chinese government said in 2014 that 20% of the country's farmland was contaminated and 1/3 of its surface water unfit for human contact. So, so we, you know, if seabed mining ramps up, we won't be able to see anything. You know, we hardly know what the impacts are going to be. And, you know, it's just a terrible, it seems like a really good thing to try to work to stop before it starts. And as far as what you can do, I think the best things are to support organizations that work on ocean protection. Think about that circular economy versus a linear economy, and encourage local businesses that depend on a healthy ocean to sign our petition. This is a petition that's on the Surfrider website, and we will make it available to you all. We're looking for businesses. You know, we don't care where they are. Businesses that are coastal, and then once we get going with the legislative work, we will let you guys know. And then also Liz and I have a one-pager that we'd be happy to share that cites some of the studies that we talked about today, and it has some more resources. So I just want to thank you all for listening to, especially me, ramble, and hope that you learned something and enjoyed the presentation, and we would love to hear from you.
And I dropped a link to a blog post that has most of the information we covered, as well as a link to the sign-on letter that Lee just talked about. So that's in the chat.
Awesome. Well, thank you, both of you. Do we have any questions?
Yeah, are you going to have this slideshow available? Can you post it? So, okay, good, because I had a question and now I can't remember what it was.
Yeah, it'll come to you though.
Yeah,
I think I saw somebody else that might have had a question. Maybe not.
That was good. Thank you.
You're welcome.
Yeah, it's definitely refreshing to look at things like this before they've had a chance to really have an impact and figure out what we can do to mitigate it. I guess one question that I do have is, were you able to dig up any information on what the threats might be a little bit more locally within the Puget Sound area?
It's really hard to find specific information. For one thing, just finding any information on like what resources are down there. Here, if you guys remember, I'll try to share my screen and I can show you that map that Lee showed you guys. But you know, within our state waters, let me share my screen real quick. Within our state waters, we see these, all that pink area. You guys see that? Okay. So you see all the green dots that are known resources, like these hard mineral deposits, and some of them are within our state waters. A lot of them are in our federal waters. Luckily for the outer coast, a lot of them are protected by the marine sanctuary. And you can see that there's like a complete lack of green dots in like the Straits and Puget Sound area. And I honestly don't know, and I haven't been able to find information as to whether that's because we don't know, you know, have we looked and not found, or just have we not looked yet? And so it's hard to say like where the resources are and the extent of them. A lot of the papers that we've pulled are old, like the Black Sands papers from like the 60s or in the 80s, you know? And so it's an industry that hasn't really targeted our waters aggressively and done like, again, it's expensive to research this stuff. And so we have not been that successful in finding specific information on what resources are down there. And so that makes it hard to say what the potential impacts could be. But the sediment plumes would be one of the biggest concerns because they have the ability to drift far and wide. So the extraction plume, most of the models we know about like sediment drift are focusing on those extraction plumes. So at the seafloor, those can drift 10 to 100 kilometers. But you also have the dewatering plume, which is released somewhere in that water column. And that has the potential to drift much further. And some of those will dissolve. So some of them will drift a little bit farther before settling, and some of them will dissolve and drift far and wide on currents. And that's essentially like mine tailings, right? Like so you're releasing mine tailings out to the open ocean. And so we do know that some metals can enter into our food systems and bioaccumulate like mercury up the food chain and end up on our plates. And so again, there's no like hard and fast empirical studies to point to for a lot of these effects. But you know, the other concern is for me, just our state economy is very reliant on these like a healthy coastal ecosystem, and our state economy, you know, it's statewide. And so even if it's just our shellfish industry in Willapa Bay, Grays Harbor area, you know, that produces what, like a quarter of the nation's shellfish. Like if that were to be impacted by toxic sediment plumes because they're filter feeders, like that would affect our statewide economy. And so to me, you know, what happens anywhere in our coasts like affects us all, especially if we're talking about that sort of severe potential impact. And then of course, like you have your noise pollution. And so that can travel very far, like noise travels 4 times faster underwater. And so the impacts to our marine mammals, you know, again, hard to say, probably not positive. And so yeah. And then of course, just like carbon and ecosystem dynamics, like we don't know what these sediment plumes or these chemicals released into the water column, how it might affect things like kelp or tunicates or microbes, you know, so it's just really hard to predict those specific effects, but they would be negative. It's just the scale of that negative effect is harder to say.
I remember the question I wanted to ask was, you said something about there was a pilot program for the cobalt extraction that was started, and you gave a number of how much that they had extracted. Do you know who's doing that and where it is?
Yes, so I can show you on this map. You guys see that okay? I'll enlarge it. So that is I didn't have it. Lee's map, she put it on there, but it's the JOG mech. It's off of Japan. so it was in Japan's exclusive economic zone. So it's within 200 miles of Japan's coastline. And so it was a combination of like academic and government and private industry, and it was sort of an experimental extraction. And so they were able to remove, I think, 650 kilograms of that crust. So they've developed the technologies, and now they're in the process of like assessing if they were able to collect the amount of resources they predicted they would able, like once they extract all the important stuff from the things they brought up, to see how much nickel and cobalt they got out of it versus what they thought they would. And one of the recent articles I saw was that the cobalt, they think that, you know, if their predictions are correct, the amount of cobalt they brought out would supply Japan's needs for cobalt for like 88 years. And the nickel would supply Japan's needs for 12 years. And so that is why these companies and governments are looking to the deep, is because just the amount of resources down there, and they often are more concentrated than you would find them on Earth. And so there's a you know, a viable argument that's like, we need to extract these to fuel a decarbonization. But there's also another side of that argument that's like, with effective recycling and better, you know, like a more circular economy and better end of life, you know, extraction of these valuable resources, we should be able to at least delay and like reduce that demand until hopefully we could leapfrog those technologies that right now to decarbonize, we need those lithium batteries, you know, like we need these resources for that with the existing technologies we have. But if we can reduce the demand until we can develop, you know, whatever it is, like hydrogen fuel cells or something that might not require these resources. And so that's what a lot of the global community that's working, you know, with these international waters, because that's where a lot of these resources are located. A lot of them are pushing for like a moratorium or at least a suspension of, you know, permitting these deep sea mining activities, hoping we can just like recycle long enough to not need them anymore, is sort of one of the pathways we could choose to go. But the cool thing about metal is that it's infinitely recyclable. Like with plastics, you can recycle it once or twice, and then it's sort of, you know, it's not valuable anymore. It's degraded too much. But metal, if we were better at, you know, designing our products to recover them and extract those resources, you know, we can continue to use them in perpetuity, essentially.
I have a question, and for some reason I can't figure out a way to raise my hand. So,
got it out.
There's been quite an extensive effort in terms of whale protection around the orcas recently. And I'm just curious with regards to your comments in addressing this issue with the legislature. Have you seen anything? I mean, I've followed the whale protection stuff a little bit. It's mostly around recreational, commercial vessels in the waters, in particular around ocean noise. But have you seen anything about this seabed mining concept in this whale protection effort? No. Okay, I haven't either. And I'm just curious if you had thought about trying to tag that in somehow.
That's an excellent point. And again, there isn't a lot of research as far as like what the acoustic pollution would be like from these different, you know, because there's different depths and they're at different locations. And I don't know a lot about, you know, the acoustic noise that this would generate and what those effects would be on marine mammals. But that is an excellent point that, you know, again, the good news is, you know, there's no industry that I'm aware of that's like, we need to move now. So we don't have, you know, there's not a lot of opposition to our work, especially with the coastal water. Like we're trying to just ban it in state waters for now and, you know, at least keep it out of our nearshore ecosystems. And so we do have like a sponsor and we're drafting bill language like now, and it might happen this year, it might happen next year, but we'll see. But if we do need more support, that is an excellent potential partner, because again, like the orcas, they don't need any more. They don't need any more issues.
Right. Right.
Are there any other questions?
I have a question. So what does DNR say about tidelands being used for mining? What's on the books as far as tideland leases?
That is an excellent question, and I should have a better answer for you. Lee might know more. As far as I know, DNR, we don't have any specific language that talks about like seafloor extraction. And so as I understand it, they would review, if you were to like apply for a lease for extraction of these sands or some other resource, they would review it on a case-by-case basis. I believe that's sort of how it is right now. But I could be, you know, there's other rules about like tidelands that are a little different from, you know, offshore. And so I can't answer with 100% certainty.
Yeah, that might be one place to do some research and to see if maybe certain restrictions on that activity connected with the tideland lease would be a good idea.
That would be an excellent idea. Thank you.
Or the subtidal lease.
Excellent.
Yeah, because DNR is the agency that we really need to target because they have the jurisdiction right now over these waters. That's a great idea, Mike.
Yeah. And I know they did just have like a review, I think last year, of like artisanal mining. It's kind of a fun phrase, but I don't believe we're talking about like we're focused on industrial scale mining. So I can't speak for what impacts or lack of impacts it would have on like anybody trying to like pan for gold near the water or anything like that. Our focus is industrial, large scale.
Great. Are there any other questions? Going once, going twice. I don't see any hands raised. I don't see anything in the chat box. So I think we don't have any other questions, but if folks think of something later on that they want to ask Liz and or Lee, and you don't have their contact information, you can always email Austin or myself and we can get you in touch. But thank you so much. It's kind of always weird in presentations because it's like clapping isn't really the same. So thanks so much. We appreciate you updating us on seabed mining in Washington State. And it's interesting to think about other marine resources, like the mineral marine resources, because I always think of marine resources as more like the fish and the shellfish and things like that. So thank you for bringing that perspective. So next we'll move into more of the MRC business. So folks are